For over 60 years, IBM research has driven innovation in the computer industry. In 1944, IBM introduced the Mark I, the first large-scale automatic digital computer. Since then, IBM has led advances in software, in storage technology, and in semiconductor devices and processing. IBM's technical innovation has also resulted in 2 Nobel Prizes and in computer systems that are the most powerful in the world. In the semiconductor industry, IBM has been at the forefront in advancing silicon-based integrated circuit technology for more than 50 years. From the early days of bipolar devices to the sophistication of today's CMOS processes. But as the size of these devices continues to shrink, an increasingly complex array of materials are being added in order to provide improved performance and function. Significantly, most of these advances have begun here at IBM's T.J. Watson Research Center in the Microelectronics Research Laboratory, the MRL. Since the 1990s, IBM has helped transform the semiconductor industry with such breakthroughs as copper interconnects, silicon on insulator, strained silicon, and high-K dielectrics. Today, the variety of materials handled in the MRL goes well beyond what would be allowed in a typical development or manufacturing facility, as the MRL applies its expertise to the growing scope of emerging technology, from faster transistors to novel memory devices to solar cells. In the MRL, wafers move through the full range of processes needed to build integrated circuits, developed and run by a team of scientists and engineers. Each lot of wafers is essentially a new experiment, which provides an early view and assessment of technology options that help focus future development and manufacturing on the most promising approaches. Underlying the technical work are discipline and systems that keep the lots moving, providing fast turnaround and cycles of learning. Some MRL capabilities are rare in the industry, allowing IBM to explore technology that few other labs can. One such area is three-dimensional integration. Using cutting-edge tools, the MRL has the capability to bond wafers to wafers or chips to wafers, so that devices can be stacked on top of each other for increased density and shorter interconnections. But perhaps the most important tools for many applications are the 2-electron beam lithography systems. These tools use a very finely focused beam of electrons to expose circuit patterns with sizes smaller than can be obtained in any other way. Being able to print these features allows researchers to study how devices and circuits will behave years before they could be studied in a typical development lab, giving IBM an advantage in understanding and addressing the issues that will be faced in the development stage. The MRL also has the ability to handle different kinds of substrates. While most of the MRL's work is done on 200mm diameter wafers, the lab can also handle square wafers for photovoltaics and selective processing on wafer pieces. The dedicated employees of the MRL support projects for both IBM and its partners. The IBM MRL is a world-class nanofabrication research facility, flexible and disciplined, with depth and breadth of scientific and technical expertise across the full scope of semiconductor technology. It is uniquely positioned to enable a varied range of customers across a broad spectrum of new applications and stands ready to embrace the challenges of the future.